Welcome to the lecture on regularity accounts of laws of nature, specifically that article by Swartz. So we read Hume because Hume started the whole ball rolling by questioning some of the assumptions people might have had about science and how science works. But Hume kind of conflates a few different items that we now have the terminology to sort of keep distinct. So Hume is worried about anything that we can't see, right? Because he's an empiricist, is going to be suspect as to whether there's even a content to the concept there. He allows, of course, we can have concepts, sensible concepts for things we don't see. We build up complex concepts, but he's always a little suspicious, right, if we can't see it directly. So there's a few things we can't see directly when we're talking about science, which is, laws of nature, forces, causation. And Hume kind of blends those together, but they're really distinct things, right? So forces will feature in laws, right? One of Newton's laws, force equals mass times acceleration. So force is something in the law, it's distinct from the law. And then causation is also something distinct from the laws that supposedly either govern or describe causal relations. So today we're going to talk about Swartz is, current philosopher living, I believe. And so he's working in the sort of our more contemporary notion that has a few more sort of categories for these sorts of things. So he is still working against a sort of implicit assumption that most people have never really thought about, right? They just sort of always assumed, which is that when you talk about laws of nature, that they're like doing something, right? But it's the laws of nature that prevent me from jumping to the moon or prevent me from living forever. And we might sort of think that way a lot of the time. He provides, I didn't include them here, but he provides a lot of quotes from scientists and philosophers that reveal this sort of implicit assumption is that the laws of nature are actually doing something. And he's going to take a lot of time, right, to demonstrate that that notion is actually really weird, right? And it can't be right. And instead, he's going to try to substitute a simpler account of laws of nature, which all laws of nature are doing is describing regularities in nature. They're not making anything happen. They're just describing what does happen, right? So obviously he's inspired by Hume, right? And we saw that Hume, didn't see any rational basis for these sorts of mysterious things like laws. But Hume's account relied on empiricism. Most of his arguments, if you just said, well, Hume, I'm not an empiricist, then you wouldn't have, that was like an important premise in his argument, and he wouldn't be able to convince you. So Swartz is going to be much more general, right? You don't have to be an empiricist in order to buy his arguments. And he's going to try to convince you that laws can't be anything more than just descriptions of regularities that we observe in the world. So to begin with, he wants to make a distinction, and this will come up later, I think, in the Dresky, between physical laws and scientific laws. So physical laws are what he cares about. Those are laws of nature that we mean when we say laws of nature in this course. They are the things that would be there whether or not there were any humans or any scientists to discover them, right? Laws of nature existed back when there were only cave people. Scientific laws, in contrast, are what scientists produce. So scientific laws are, sets of sentences or sometimes equations, and they describe the laws of nature, right? They might be right, they might be wrong. Usually they're wrong, and we have to revise them, and they get better and better, but they change, with time. So physical laws aren't like that. Physical laws always stay the same. They are what they are, whether or not any human ever existed to discover them. Scientific laws are they're like a sociological thing. So if you could study scientific laws if you wanted, right? Maybe you do it in a sociology course where you're studying the behavior of scientists. But that's just not what Swartz is concerned with. He's concerned with physical laws, right? Laws of nature that exist independent of science. And another clarification, when he says physical law, it might sound like he's talking about laws of physics, but he's not. He's talking about any law. So if there's laws in psychology, there are laws in psychology, Weber's law, laws in economics, those would count as physical laws as well. He's just talking about any law that is in nature that exists, right? Of course, laws of psychology and economics wouldn't exist independent of humans. They're laws that govern human behavior, but so long as there are humans, there are laws of psychology. So here is Schwartz's formula for what counts as a law of nature or a physical law. And he says it's nothing more than this, right? This is enough. So what is it? It's going to be a statement that's true, right? So this is actually, so again, to keep this distinction between, right, the laws of scientists formulate, which are sentences, and the actual laws of nature. So here, this is really technically a set of conditions on, right, a description of a physical law, right? Because laws themselves aren't true or false, right? They just are that are true and false. But at any rate, so if you're going to describe a law of nature or state a law of nature in language, it better be a true statement, right, or a set of statements, and true everywhere and for all time, right? So not just true of today in this room, right? Given a certain, whatever's going on in this room, the air pressure and so on. They should be universal or statistical generalizations. So that's just talking about the logical format of what counts as a law. So if you've taken logic, you know what a universal generalization is. It's something like all F's are G's, right? All cats are mammals. All objects accelerate towards the Earth at 9.81 meters per second. They might be statistical generalizations, so they may not guarantee. They might say certain things happen regularly with a certain probability. Some law that described the decay of radioactive substances are like this, right? So a radioactive substance will decay with a certain probability in a certain amount of time. So those will be statistical generalizations. But either way, it'll have that format of all F's or G's for all X, right? If X, then if they will be purely descriptive, which means they don't have any names in them, right? So there are no physical laws about Nate that mention Nate specifically, right? They're going to govern instead, human beings that are 5'10", right, and such. There could conceivably be a scientific law that governed human beings of about my size, right? But there's never going to be a physical law that mentions me specifically. Number 4, they're going to be conditionals. So again, this is just about the logical format. So when I say all F's are G's, right, all objects fall towards the Earth at 9.81 meters per second squared, that will be formulated in logic as for all X, if X is an object, then X will fall towards the Earth at 9.81 meters per second squared. So that's a conditional then, right? Prefixed by universal for all X, right? So for this course, you don't need to know that logic detail, but that's what he's talking about here, is just the logical format. And finally, it should be contingent, which means it's not a necessary truth. So there will be no physical laws that say all bachelors are male, right? That's a necessary conceptual truth, right? There's no physical laws that say 1 + 1 = 2. Again, that's a necessary truth. So these are going to be contingent truths in a different universe, right? Where things behave differently, you would have different physical laws. So it's kind of a lot. It's 5 things, right? But he says that's all there is. So there's no extra thing that you have to add there about how the laws govern things or how laws necessitate things, right? How laws make it that such and such must happen, right? Instead, they're just true generalizations that describe what happens, what has happened. So he's got simplicity on his side, right? He says, look, this is all we need. So all things being equal, usually we prefer a simpler theory, right? And now he's going to spend some time telling you what's wrong with the idea that laws govern, these necessitarian accounts, right, of laws of nature. So this one comes from the nature of truth. So what is truth? Well, truth is a relation between sentences and facts. So facts are the way the world is, right? There's a fact that my shirt is blue, or it's black, actually. It looks blue on the screen. There's a fact that my shirt is black. There's a fact that the acceleration of gravity is 9.81 meters per second squared near the Earth. And then there are sentences that describe that. So the sentence, "My shirt is black," is true just in case the facts of the matter are that my shirt is black. Right? So his example is, here's a sentence, and it's in little scare quotes, right? "The charge on each electron is negative 1.6 times 10 to the negative 19 coulombs," right? That's a sentence. Sentences can be true or false. What makes it true? It'll be true if and only if the charge on each electron is negative 1.6 times 10 to the negative 19 coulombs, right? There's no quotations around that statement. That's talking about the world, right? So when we put things in quotes, we're talking about sentences, and then when they're not in quotes, we're talking about the world. So the sentence is true if the world is the way that the sentence describes. That's a pretty standard and widely accepted account of truth. We're not going to talk about theories of truth in too much detail, but right, that I don't think too many people would deny that. So he says the problem with the idea of laws of nature is somehow governing or necessitating things is it totally turns this truth relation upside down, right? And it says that, no, in fact, the reason that electrons have that charge is because there is a law of nature that says electrons have a charge of negative 1.6 times 10 to the negative 19 coulombs, right? So we end up with two types of truth relation, right? One for regular sentences and then one for laws of nature, right? Regular sentences, it's the world that makes the sentence true, but with laws of nature, it's the law that makes the world the way it is, right? And the law, is kind of described as, it appears as a sentence, right? So these laws are sentence-like, right? They're propositions or something, and their truth makes the world the way it is, instead of truth just describing the way the world is, right? And he thinks that's messy. Again, simplicity would be on his side. I'm going to have just one straightforward account of truth, right? That truth depends on the world, not that the world depends on the truth of the law. So just, some terminology, right? So these governing laws, these necessary propositions that make the world the way it is, he says, call somebody who believes in those a necessitarian, right? And later we'll see Dretsky as a necessitarian. So like, there's a few funny things about these supposed necessitarian laws. First of all, they don't depend on the world at all, right? So there could be laws about the behavior of bears, governing the behavior of bears, even if there were never any bears, right? They're totally independent of the world, right? They make the world the way it is, but they don't depend on the world at all. And so presumably there's all sorts of laws about creatures that don't exist yet, right? So before humans evolved, there would have been laws about, right, the biology of humans, right, for billions of years before there were any humans. That maybe feels a little strange. So in that way, they're what he calls autonomous, right? And they're also subjunctive. So subjunctive just means it describes like a counterfactual, the way things could be, right? So the laws of nature are out there. They don't depend on the world, and they also sometimes govern stuff that doesn't even exist yet. It's like if there were bears, then these laws would govern them, right? But the laws were there before there ever were bears, and he thinks he doesn't like that view. That he's trying to bring out the weirdness, right, of necessitarian laws of nature. Right? Autonomous and subjunctive nature can't be right. Now, at a certain point in philosophy, we're just appealing to your gut, right? Doesn't that feel weird? Wouldn't you rather have a theory, right, that wasn't quite that weird? And that's what he's arguing here. So, he says, look, regularity theory is much better. Laws are not autonomous, right? Laws are not independent of the world, and they're not subjunctive. They're not going to be governing behavior of things that don't even exist yet, right? Instead, he says physical laws are just descriptions. They're just descriptions of the world that exists. Benefits of that falls right into line with our intuitive notion of what truth is, right? So you've got a sentence that describes a law of nature, and that law of nature is true only if and only if the world is the way it says it is, right? It depends on the world for its truth, not the other way around. So he says, maybe a lot of you intuitively before you took this class were uh, implicit sort of necessitarians, right? You thought laws actually did something, right? And he says, so it might feel a little weird to switch over to the regularity theory where laws don't do anything except describe. Um, but he says all you need to do is do a little Gestalt switch. So a Gestalt switch is like if you've ever seen this duck rabbit picture here, right? So if you look at it in one way, it looks like a duck, right? The bill is on the left there, and the duck is looking to the left. But you can also see as a rabbit, right, where the bill turns into ears and the eyes there. And it's kind of a bivalent thing. You can either see it as a duck or you can see it as a rabbit, but it's hard to see it both at the same time. But it's a fairly simple switch once you make the switch, right? It feels like, oh yeah, obviously it looks like a rabbit. So he says that's what's happens when you switch over to the regularity view of laws of nature. You just need a little gestalt. Um, and you can see, yeah, the world is still orderly. Nothing about the world has changed when we change our theory of laws of nature. Um, all we have to say is there's nothing necessary about this orderliness in the world. There's nothing that's making it happen. There's not, or certainly the laws of nature aren't making it happen, right? Something that happens and our laws describe it. And he says, are we missing anything? Did we lose anything after that Gestalt switch? And he thinks not. He thinks talking about necessity doesn't really add anything, right? So, for example, if you said, well, why do electrons have the charge they have? And I said, oh, because there's a law of nature that electrons have to have that charge. Did I explain anything at all, right? Or did I just restate a fact about the world, right? So he's saying that the laws, right, make it the case doesn't really add anything to our understanding. And then he moves on, right? This is sort of a cost benefit analysis, which sometimes people do, right? So when we're talking about theories, we like a simple theory unless we need it to be more complex to explain more stuff. But in general, if we can explain everything, right, with a simpler theory, we tend to favor that. That's what, it's Occam's razor, if you've ever heard of it. The general principle that by and large, philosophers and scientists abide by. Keep it simple. That's So he thinks, regularity theory is the simpler theory, and that necessitarian theories don't add anything that helps, right? So they make it more complex, but without giving us any benefits. So he says they don't necessitarian view of laws of nature. It doesn't simplify our theory. It doesn't extend our understanding of the world, right? It doesn't really tell us any more information about why electrons have the charge they have. It just restate that fact. And one reason to believe in something is if you can see it, right? And Hume pointed out we have no sensory access to these supposed necessitarian laws of nature. So he's saying, why bother with them, right? And then on the other hand, he thinks regularity theories do have a few extra advantages, right? That make them worth, right? That make them more theoretically, we call these theoretical virtues, right? So first of all, it gets rid of some of this metaphysical baggage, right? So some ideas that we don't need that are like kind of mysterious and a little spooky, and keeps us in line with sort of a rigorous, pared down, empiricist, sort of hard-nosed scientific view. And that sort of approach, he thinks has been successful throughout history, right? So people used to talk about vital force, right? What is the special force that makes living things live, right? And it turned out we didn't need that at all. Once you understand the biology, you don't need an extra force to explain why living things are alive, right? Natural place. So in old Aristotle's physics, right? It was like, well, objects want to be close to the Earth, or their natural places near the Earth, and that explains why objects fall towards the Earth. Turns out we don't need anything like that, right? If we understand gravity, we don't need the extra idea that everything has its own special place. So he thinks necessitating laws are another one of those extra sort of mysterious, spooky things that ends up being unnecessary. Second, another advantage of regularity theory, according to Swart, is that all the sciences are on pretty much the same footing, right? So some people think, and some necessitarians think, I don't know, I'm not sure that all necessitarians would have to believe this, but many people are reductionists, which means that all the laws of nature should eventually boil down to physics, right? If you understood all the laws of physics, then you would be able to predict the laws of biology and chemistry and all that, right? Um, and to a certain extent, this is true, right? So chemistry does boil down to physics, right? Chemistry is, if you understand the way elementary particles interact, then you'll understand the way molecules interact, and you'll understand chemistry. Right? So reductionism is a powerful idea, and it's successful to some degree. But there have been arguments. We're not going to cover them in this class, but that you'll never be able to reduce all of the laws, all the scientific laws, down to physics, right? By the time you get to things like psychology, economics, it's going to be impossible to actually sort of ground them all in physics. Um, and if that turns out to be the case, right, that there is no reductionism, then you're going to want a regularity theory, right? Because in regularity theory, you don't have to worry about whether it's reducible. Any regularity can count as a law, right? As long as we observe the regularity, it's a law. It doesn't have to also reduce to physics, right? Um, Another thing is statistical laws and deterministic laws are on the same footing for regularity theorists, right? A regularity is a regularity. There's nothing, some people find statistical laws unsatisfying, right? When you get to quantum mechanics and they can't say anything more precise than, well, I think there's this percentage chance that this atom will decay, right? This radioactive substance will decay within a certain time, but I can't really predict it with any more precision. Some people find that unsatisfying. The regularity theorist doesn't need that unsatisfying, right? They don't think anything's missing, right? We've noticed irregularity and we've described it, and we've done our job as scientists. And finally, he thinks regularity theory solves the problem of free will. So, we're not covering it in this metaphysics class. Maybe you've covered the problem of free will in an introduction to philosophy course or another metaphysics course. But the basic idea there is like, if there are laws of nature, right, that govern everything, then whatever choice you make must have been decided by, right, physics and the neurons in your brain, the laws governing the neurons in your brain, right? And you never really actually made a choice. It was already decided at the Big Bang, right? Um, if you think that laws necessitate things, then laws are also going to necessitate all of your choices and all of your decisions, and you don't have free will. But on the regularity theory, laws aren't necessitating anything. They're just describing things. So they can describe all of your free choices, right? That's perfectly legitimate on a regularity theory. So that's it for the Swartz, right? He's tried to, again, hopefully that clarifies what Hume was starting to get at, and it brings it into a more contemporary, more rigorous account, right? He gives us his 5-point account of what a law of nature is, and he says you don't need any more than that. And thinking you need more than that is a bad idea, right? He tells you all it's a weird account of truth and so on. And then also getting rid of all that stuff has all these advantages, right? So that's his argument for regularity theory.